Okay, this is measures of central tendency and dispersion from group data. Now, what are we talking about there? Well, if you got a distribution here, let's see, this is 10, 20, 30, and this would be 19, 29, and 39. And we got our frequency, 20, 13, and 5. Okay. Now, if we want to find our average or our standard deviation, our mean standard deviation, if I look at this, the question would become, well, how many 10-year-olds are there? How many 19-year-olds? We don't know. We know there's 20 between 10 and 19, but we couldn't tell you how many 10-year-olds and how many 19-year-olds. So this is going to show you a method for finding the mean and standard deviation based upon group data. Now, it's not going to be what the real answer was, unless you're just real lucky, because we have no clue what the original set of data was. If we had 20 10-year-olds, again, that's going to be different than if we have 20 19-year-olds, if we're figuring the average. Well, our first one here is mean from frequency table. We got x bar is equal to, and then we got our sigma notation, that's adding together, f times x, where f is frequency and x is class midpoint. And then down below we divide by the sum of the frequencies. Now here's how we do it with technology. We'll come back to that. Let's first do it by hand, then let's do it via technology. Okay, so our first problem. We got ages 0 to 4, 5 to 9, 10 to 14, 15 to 19, and 20 to 24. And we got our frequency, which is 3, 8, 5, 12, and 2. And the instructions are to find the mean. Now, I don't say sample mean or population mean because it's the same formula. So let's come up here. And frequency is our F. So this right here is our F. We need a class midpoint. So let's find our midpoints. And this will be our X. Well, midpoint, remember we take our lower class limit of this class plus the next one. So we got 0 plus 5, and then we divide by 2. Well, that gives us 2.5. Now we can use our class width very easily to come up with the other ones. See how this goes from 0 to 5 to 10? It's adding 5 over and over. So 2.5 plus 5 gives us 7.5. Plus another 5 gives us 12.5. Gives us 17.5, gives us 22.5. So those would be our midpoints. Now this says f times x, which implies I'm going to need to have a column where I multiply f times x. So I got 3 times 2.5, I got 8 times 7.5, I got 5 times 12.5, I got 12 times 17.5, and I got 2 times 22.5. Okay, I'm going to use my calculator pretty heavy here because I don't want a math error in these videos. So 3 times 2.5, 7.5. 8 times 7.5 gives us 60. 5 times 12.5, 62.5. 12 times 17.5, 210. And 2 times 22.5 gives us 45. Okay. Now we got f times x, and then we got the sigma in front of it, uppercase sigma. That means we're going to add those together now. So we want to sum this column, and that'll be our f times x. So 7.5 plus 60 plus 62.5 plus 210 plus 45. And that gives us 385. Now the other thing we need for this is sum of the f's. So we want to sum together the frequencies. 3 plus 8 plus 5 plus 12 plus 2. That gives us 30. And now we have everything we need for our formula. So let's plug it in our formula. So x bar is equal to the sum of f times x over the sum of f. So that'd be 385 over 30. Divided by 30, we get, I'll take it to one decimal place, 12.8. And that'd be our mean. Sample mean, population mean, same difference. Okay, so that's how we did this one by hand. Well, let's use technology now. And we'll actually use part of this for our technology. Okay, mean from a frequency table. It says put midpoints in L1, frequency in L2. Well, you have to find your midpoints first. So here they are. So let's go over to our calculator. Excuse me. Press Stat, go into Edit. If you got numbers in L1, go ahead and press Delete till they're all gone. If you have numbers in L2, you can right arrow over and press Delete on them till they're all gone. Okay, so L1. No memory. L1 midpoints. Okay, so let's put our midpoints there. So we got 2.5, 7.5, 12.5, 17.5, and 22.5. Now I'm going to right arrow over to L2, and it says to put frequency in L2. So our frequency, we got 385, so 385. We got 12 and 2, and 2. Okay, now I didn't put it here, but anytime you're inputting your numbers, you should exit out. So we'll exit out. Let's do second mode. Then it says do stat button, choose calc, choose one of our stats, and well, you can read those. So I'll press stat. Did I push it? Okay, my calc is just going real slow. Okay, press my stat button, press right arrow to calc. We want to choose one of our stats, so press enter on it. And we want to put in L1, comma L2. So I'll do second 1 to get L1. Comma's right here above the 7. The button above the 7 button. So comma, and then I'll do second 2 for L2. And then push enter. And we see our mean is 12.8, which is what we got by hand. So that's how you find the mean of a distribution table by hand and using the TA3, TA4 calculator. Okay, well, the next thing. Sample standard deviation from frequency table. And there's my example down there. Well, let's first talk about this. We got s is equal to a square root, and then we got x sub I minus x bar squared times f, and then sum it. And then sum of f's minus 1. We're going to look at that formula a lot closer. And then we've got our population standard deviation, which is the x values minus our mean, population mean, then squared, then times the frequencies, and then divided by the sum of the frequencies. Now the formulas are very similar. The only difference is, and this is true kind of throughout, is see how we minus 1 here on the bottom, and here we don't do the minus 1. Now here's the instructions for doing it with technology. Skip over that. And then variance. Square the standard deviation you found. Be sure not to round the standard deviation any before you square it. Okay, like I say, we skipped over some of that. We're going to go back to it. I first want to show it by hand. And this is not necessarily a simple process by hand. Do I have enough room? Probably do. Okay, I'll try to do it here. So we got our ages. 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 2, 4, 10, 2, 4, 10, 3, and 1. And that's our frequency. Okay, now find a sample standard deviation and sample variance. Let's go back up to our formula. Like I say, we'll look at it in detail now. Well, we need our x values, which is the midpoints. Remember our midpoints, we take the lower class limit of the current class plus the lower class limit of the next one, divide by 2. So we got 0 plus 10 divided by 2, which gives us 5. Next one would be 10 plus 20 divided by 2, which gives us 10. Or you could just simply use your class width. See how this goes from 0 to 10 to 20? I'm adding 10 over and over. Ooh. Okay, obviously I can't do basic math this morning. Or this afternoon, whatever time it is. 10 plus 20 is 30. 30 divided by 2 is, oh yeah, 15. What am I doing? Okay, add 10 over and over. 25, 35, and 45. So those are our midpoints. Those also happen to correspond to our x's from our notation. That's our x. Now we need x bar, which is sample mean. So we have to go back, do this formula first to get sample mean. Okay. So this formula says we're going to take f times x, frequency times class midpoint. So I need an f times x column. Well, this is our f's here. So we're going to take 2 times 5, which gives us 10. We'll take 4 times 15, which gives us 60. We'll take 10 times 25, which is 250. We'll take 3 times 35, $105. And we'll take 1 times 45. And that gives us 45. Okay. This then says we need to, the sigma in front of it says we need to add those together. So that's going to be f times x. So I got 10 plus 60 plus 250 plus 105 plus 45. So that gives us 470. And from our formula, we also need to add together the f's. That's for the denominator, what's downstairs. So add those together. 2 plus 4 plus 10 plus 3 plus 1. That gives us 20. Okay, so then our x bar from our formula, this one right here, we're going to take sum of f times x divided by the sum of f. So that gives us 470 divided by 20, which gives us 23.5. Okay. Let's go back to our formula. Okay, so now we got our midpoints, got the x bar, so we need to have a column for x minus x bar. So I'm going to take each x value. This would be 5 minus x bar, which is 23.5. And I got 15 minus 23.5. I got 25, 35, and 45. minus 23.5 minus 23.5 minus 23.5. This gives us negative 18.5. This next one gives us negative 8.5. Next one is 1.5. Next one's 11.5. And next one's 21.5. That's what's inside the parentheses here. Well, now we want it squared. So I'm going to have a column. Some people put this all in one column, and that's kind of up to you, but where I'm going to square these. I like to build a piece at a time. So I got negative 18.5 squared. I got negative 8.5 squared. I got 1.5 squared. I got 11.5 squared. And I got 21.5 squared. 18.5 squared is 342.25. 8.5 squared, 72.25. 1.5 squared gives us 2.25. 11.5 squared gives us 132.25. And 21.5 squared gives us 462.25. Okay, last. We got it squared now, so now we're going to multiply times f. This is x minus x bar squared times f. So we'll take 342.25 times f, which is 2. And we'll take 72.25 times f, which is 4. We'll take 2.25 times f, which is 10. We'll take 132.25 times f, which is 3. And 462.25 times f, which is 1. That's 462.25. 342.25 times 2. 684.5. 72.25 times 4. 289. 2.25 times 10 gives us 22.5. And 132.25 times 3 gives us 396. Excuse me. 0.75. Okay, so we've done all of this. So now the sigma out in front says now add it together. So I got 684.5 plus 289 plus 22.5 plus 396.75 plus 462.25. Oh, that's weird. 1855 comes out nice. Assuming I typed everything in correctly, which is always questionable. These are so easy to make a mistake on. Now the other thing we need is add the f's together. Well, we already have that over here. We added the f since 20. So now we're ready to plug it in our formula. So our sample standard deviation is equal to square root of top part, x minus x bar squared times f, over square root of f minus 1. Okay, so that gives us square root of 1855 over 20 minus 1. Probably better to do a little bit of simplifying before you plug it in your calculator. 20 minus 1 is 19. And now I'll go to my calculator. So I got the square root of 1855 divided by 19. And we've got 9.880869342. Okay, so that's approximately 9.9 for S. Let me do one more thing before I show you use technology. I'm not going to do the population standard deviation. Basically the same formula, except we don't do a minus 1 down here. Variance. Square the standard deviation you found. Be sure not to round the standard deviation any before you square it. And I put all these decimal places here because when I'm finding the sample variance, I'm going to take all these and press my x squared and press enter. And then we get 97, and I'm going to round this because I'm not going to need it anymore. So 97.6. So this is our sample standard deviation, that's our sample variance. Okay, let's use technology now. We'll need part of this up here. I kind of skipped over this slide. This is how we're going to do it with technology. So let's take a look at this. It says put midpoints in L1. So let's start there. I go to Stat. I do enter on edit. I got data in L2 and L1. I'm going to press delete over and over until those are gone. Left arrow over. Again, do not press delete on L1 and L2. If you delete it by accident, I've given you steps up above on how to add it back in. Okay, so midpoints in L1. Try it again. Okay, here's where our midpoints. 5, 15, 25, 35, 45. So we got 5, 15, 25, 35, 45. That's our midpoints. Okay. Frequency in L2. So our frequency was right here, 2, 4, 10, 3, 1. So I'm going to right arrow over. 2, 4, 10. I'm pressing enter after each one. 3 and 1. Okay, now it doesn't say it, but after we input those in, we have to exit out. So be sure to do a second mode to exit out. And we're just going to do one of our stats L1, L2. So I press my stat button, right arrow to calc, enter on one of our stats. Then second one, comma, second 2. A lot of people forget the comma. You have to have the comma there. And then push enter. And assuming I did my math correctly, this should match up against our by hand answer. Our by hand answer was 9.9. And this is 9.9. So that looks good. I won't have to curse and redo the video. Again, technology is much easier to do that. Now, usually on tests, I don't have people create this by hand. But you do have the example there in case you ever need to refer back to it of how to do it. Okay, let's talk about our weighted mean. Here we have x bar of our weighted mean. That's what that W represents. Now here we have sigma W times x, and then down below is sigma W. W is the weight of the ith observation, and the xi is the value of the ith observation. So let's do an example. And actually I'll need a new page because I filled it up with these. And what in the world is this? Measures central tendency and dispersion from group data. What a mouthful. Okay, measures. Actually, I got it right here, don't I? Measures extension tendency and dispersion from group data. Okay. And down here, page 01. And then click Save. Okay. So let's look at this example. It says, in a course, attendance counts for 10% of the grade, quizzes count for 20%, weight tests count for 50%, and finals 20%. Bill got 100% for attendance, 80% for quizzes, 70% for tests, and 30% on the final. He should have studied harder. What is Bill's course average? Well, let me reposition myself in my seat here. There we go. Okay. Now we need we need our W's, the weights, and we need our X values, the actual observations. So we need our W's and we need our X's. Now W's are weights. Let's go back and read the problem. We've got our attendance. And it says attendance accounts for 10% of the grade. So my weight there is 10%. And I'll put that in decimal form. Next one is quizzes. Count for 20%. So that's my weight. It's worth 20%. Tests count for 50. So this would be 0.50. And final as 20%. So that'd be 20%. Okay, now what were the actual values they got? Bill got 100% for attendance. So he got 100%. 80% for quizzes, so he got 80% there. 70% for tests, that was his average. And 30% on final, so he got 30. And then it says, what is Bill's course average? We'll use weighted mean for that. Okay, now this means W times X. It means I need a column W times X. Nothing exciting there. We're going to take 0.10 times 100. We'll take 0.20 times 80. 0.50 times 70. And 0.20 times 30. I'm not very good with decimals. So I'm going to use my calculator. I don't want to make a math there after I've done so well on the harder problems before this. So 0.10 times 100 is 10. I think the next one's 16, but let's see. 0.20 times 80. Yeah, 16. I think the next one's 35, but let's see. 0.50 times 70. Yep, 35. Next one, 0.20 times 30. And we get 6. Okay, so that's W times X. We got sigma in front of it, which means add them together. 26, 32, 62, 67. Let me double check. 10 plus 16 plus 35 plus 6, 67. And then down below here, we got add together the weights. So over here with our weights, we're going to add these together. 7, 9, 10. So this adds up to 1. Then our weighted mean is going to equal to the sigma W times X over sigma W. So we got 67 over 1 or 67. So his grade for the course would be 67. And I think that's the last slide. Yes, it is. So let me save this. There we go. And stop the different recorders. I guess I gotta find this recorder first. Sometimes WebEx hides theirs. There we go. Stop the and stop the other recorder.